Quadratic functions. Quadratic functions are functions in the form y equals a x squared plus b times x plus c, where a, b, and c are just numbers. Now the important thing about this is it has an x squared value in it. If you graph a quadratic, it becomes a parabola. Parabolas are curves that go on forever. They have a vertex, which is the turning point, and a line of symmetry. So each part is a mirror image of the other part. The line of symmetry is found with this formula. X equals negative b over 2a. The y-intercept for this is just c. It opens up when a is greater than 0. It's a positive. It opens down when a is less than 0. Okay, so let's go ahead and try one of these. So here's the easiest one. Y equals x squared. So that doesn't have our complete form here. Let's go ahead and put our whole form on it. So we don't have a plain x value, so let's say it's 0x. And then we don't have a c over here, so it's also 0. And we don't have a coefficient from the x squared, so we know it has to be 1. Okay, let's find our vertex. So the x value of the line of symmetry is negative b over 2a. b is this 0, so minus 0 over 2 times a is 1, and that just equals 0. So the line of symmetry of this equation is on this x-axis. Now, we know the vertex is somewhere on that x-axis on the line of symmetry. So to find it, all we have to do is take our original equation and input the 0 in our x value. So our vertex point is the 0 coming from here, and then the 0 coming from there. Okay. Now our coefficient from the x squared is positive, so we know this opens up. Okay. And the line of symmetry is the x-axis, so this is also our line of symmetry, x equals 0. The y-intercept, where does this cross the y-axis? Well, it crosses at c, which is 0. If we wanted to graph this, we could put in a couple points in our xy chart, where you know if x is 0, then y is 0, because that's our vertex. If x is 1, then y is also 1. So here's a point here. If x is 2, y is 4, because 2 squared is 4. And so you can see that goes here. Now, if we put in the negative values of these for the x, negative 1 times negative 1 is also positive 1. This is where we're getting the mirror image points. So this is how we would graph it. Okay, let's do one that's slightly more complicated. Let's say y equals x squared plus 1. So our a equals 1, our b equals, and remember b is the coefficient of the plane x. Since we don't have any x, our b is 0 again. And our c this time is 1. So when we, let's go ahead and find the line of symmetry. The negative b over 2a. Again, we have minus 0 over 2 times 1. So the line of symmetry is this x, or not x-axis, y-axis. And where is our vertex? Let's put this 0 back into the equation. So y equals 0 squared plus 1. So y equals 1. Okay, you can also tell that because 1 is our c, and that's our y-intercept. This is a positive x squared, so it opens up. So let's go ahead and graph this. Let's pick a point. Let's say x is 1. 1 squared plus 1. 1 squared is 1. 1 plus 1 is 2. So if we stick in a 1, we're going to get a 2 out. Here's the mirror image. If I stick in a, say a 2, 2 squared is 4, plus 1 is 5. So it's going to be up here. Okay, here's one that has both an A, B, and a C. So our line of symmetry, x equals negative b over 2a, which is negative of negative 8 over 2 times 2, which is positive 8 over 4, which is 2. So this graph will look like this with the line of symmetry right here. And the line of symmetry is the line x equals 2. Now I'm going to put that number back in for x. So y equals 2 times 2 squared minus 8 times 2 plus 6. So y equals 4 times 2 is 8 minus 16 plus 6. And so y equals negative 8 plus 6 is negative 2. So 1, 2. Here's that point. So the vertex point is, in the proper form, 2, negative 2. Now, where's our y-intercept? It's that C number. So 1, 2, 3, 4, 5, 6. And to test this out, let's put in a 1 for x. It should be somewhere right around here. So y equals 2 times 1 squared minus 8 times 1 plus 6. Y equals 1 squared is 1. 2 times 1 is 2 minus 8 plus 6. 2 minus 8 is negative 6. Negative 6 plus 6 is 0. Let's see. Negative 2. Well, my estimation wasn't very good, but that's okay. So here's x equals 1, y equals 0. So here's that side. We're going to make the mirror images. And then here's that side. So there's my parabola. Okay, another way you can see these is in intercept form. And that's when you have these two factors that are in parentheses, like this. Do you remember what to do with those? You have to use the FOIL method. F-O-I-L. Or at least most people do. F stands for multiply the first terms together. So first we multiply x times x to give us x squared. And then we're going to multiply the outside terms, x times 1, 1x, and multiply the inside terms, plus 1 times x, 1x. These are usually like terms, unless we have something really weird up here. So we can combine those like terms. 1x plus 1x is 2x. And then L stands for last. So 1 times 1. Okay, then we're back into standard form that we know. Now, if you don't like FOIL method, the other common method that people have used is kind of like a Punnett square in biology. So x plus 1, x plus 1. And you can just fill in the boxes. X times x is x squared. X times 1 is 1x. X times 1 is 1x. And 1 times 1 is 1. And then combine these two diagonal boxes to equal the 2x. You get the same answer, but some people like to see it out that way a little bit better. Okay, now let's find the line and symmetry. So what's our formula? X equals negative b over 2a. Our b this time is 2, so negative 2 over 2, a is 1, equals negative 1. And then we put that negative 1 back into our equation. Oh, plus 2, times negative 1 plus 1. So negative 1 squared is positive 1. Minus 2 plus 1, that will be equal to 0. So our vertex is ordered pair, negative 1, 0. This opens up because our x squared term is positive. So let's look at the graph. Vertex at negative 1, 0 opens up. Here's our line of symmetry at negative 1, which is the x value here. What is our y-intercept? Where does it cross the y-line? At our C, so it crosses the y-line at positive 1. That means I have a mirror image point over here. And the graph is going to look like this. Now, let's go back to our first equation up here and look at this. Let's set each one of these to equal 0. So if we do that, let me go ahead and erase so we can have some more room down here. Well, that's not going to help me, is it? Okay. set each one of those terms as 0, so x plus 1 equals 0. So let's go ahead and solve for x. X equals -1. Do you see that's where it touches the x line? That's the x-intercept of these. Remember when y is 0, we're looking for the x-intercept. And the only way for y to be 0 over there, since this is a multiplication problem, this term times that term, is for one of these terms equals 0. Since you would get the same x value to equal 0 if either one of these was -1, that's where it crosses the x line. This is why this is called the intercept form, because you can read off the x-intercepts right here.